Under the direction of Professor Stephen Benton, the recently formed Spatial Imaging Group's aim is to develop and demonstrate the powerful potential of three-dimensional imaging as an efficient means for communications. One of their recent achievements is the invention of a new type of large-scale, multicolored computer graphic hologram.
Now, ordinarily, the hologram just looks like a piece of glass or plain film, but when it's angled properly to the light, it diffracts it and sends an image straight ahead to your eye. And right here, that's a two-dimensional image, but if you move or the hologram moves, then you see a sequence of right to left views that gives you the impression of three-dimensionality, and because the transitions between those views is smooth enough, it actually looks like a hologram of a solid object.
Research is now underway to make the holograms more quickly, in full color, and also much larger. The group is also working on such technical problems as developing specialized computer graphics, assembling computer automated hologram printers, and inventing new optical systems for high-quality production and display of large-scale 3D images. Holographically stored images will be documented to allow convenient visualization of intricate shapes, forms, and spatial relationships in the fields of medicine, art, education, as well as architecture and in engineering design. In addition to their purely technical work, the group is deeply concerned with advances in the aesthetics of three-dimensional image creation and perception. A special emphasis will be placed on research in synthetic holograms, which are not made from real objects, but rather they are synthesized from hundreds of perspective views of an object rendered from a computed database, like those used for structural engineering. The images to be prepared for holographic hard copy can be quickly edited and previewed with interactive devices such as the Trillium Flight Simulator, and then rendered in full realistic detail using computer ray tracing techniques. Ray tracing can also predistort the images to match the anamorphic projection optics designed into the new holographic exposure method. The design of those optical systems is also expedited with specialized interactive computer programs. The Holography laboratory has been outfitted with state-of-the-art equipment, such as large vibration isolation tables, powerful argon and helium neon lasers, and programmable positioning equipment, which has been specially designed for holographic exposures.
This is a prototype of a new holographic format, which we're calling the alcove hologram. In it, the holographic film is stretched around a concave cylinder to project the image out in front where you can almost touch it. And the cylindrical shape makes it visible over a wide viewing zone, almost 180 degrees. We expect to make some major changes in the overall look of holograms, not just in terms of the content, whether it's medical or engineering or computer graphic images, but in terms of the size, in terms of the color, and even in terms of the format of holograms. We expect holography to move ahead very quickly over the next several years.